arithmetic progression, then we'll find the common rule for it. It is a sequence having same common difference between two consecutive terms, that is tr plus 1 minus tr equals to d, means the next term with its just previous term, the difference of those terms will be d. Let us see one example. Minus 5, minus 2, 1, 4, 7, so on. So here if you see, the difference is 7. If you see here, the difference is 3. So it is not a arithmetic series. So it is not a arithmetic progression. Now let's see another example. If you see, the difference here is 10, so on. It is 10, so it is a arithmetic progression. First term t1, we write it as a. Generally in most of the books and even examination we write the first term a, but that could change. But normally in most of the time it was a, and hopefully it will be a. Last term tnth term, that is L, and common difference d, but it could take any other letter also. Let us see terms of an arithmetic sequence. First term will be a, another term will be a plus d, next term will be a plus 2d, and it will be going. Let us write last 3 terms. So if last term will be L, so just previous one will be L minus d, and just before that it will be L minus 2d. Sum of an arithmetic series so this is a arithmetic terms of arithmetic sequence, we'll add up, we'll get arithmetic series. This will be a sum. So let us find the proof of the sum of n terms of an arithmetic series. So what we'll do, we'll be writing in reverse order. We'll write this term in reverse order. S equals to L plus D, L plus L minus D, plus L minus 2D, so on. Now we'll write it in the natural previous original order. Now what we will do, we'll add this both left hand side with right hand side. The left hand side will be 2s, and right hand side each and every term, corresponding term, first term with the first term. So if you see that minus d plus d will be cancelling out, minus 2d plus 2d will be cancelling out. So you will get L plus a, again L plus a, so on, and again this d will cancel out. So on you will get L plus a plus L plus a. So this how much time you got it? N times. Again, now adding the corresponding terms of a series. Now adding the corresponding terms of a series, we got 2s equals to L plus A, so on, L plus A. How many times you got it? You got n times. So basically you can say 2s equals to n times A plus L. On further solving, we will get s equals to A plus L into n by 2. So sum is nothing but sum of a s equals to first term, last term, average of first term and last term. Let's see one example. Sum of first 5 terms of an AP is 80 and the fourth term is 20. Find the 21st term. So we are given that first 5 term of an AP is 80 and the fourth term is 20. Find the 21st term. So let us apply the formula. S for the first 5 terms will be 5 bracket 5 terms of an AP is 80, so A plus L by 2, that will be 80. This is the first equation, we will be getting it. And the fourth term is 20, means T4 equals to A plus 4 minus 1D is 20. So that means A plus 3D equals to 20. So this is the fourth term. Now this 5 times A plus L equals to, if we cancel 5, 80 divided by 5, so we will get 16, and taking 2 here we will get 32. So that will be A plus L equals to 32. And A plus L is what? L is you have to find the first 5 terms of an AP is 80. So means n here it is 5. So 5 minus 1 into D, you will get 80. You will get so this is what? This is last term. So again further solving, A plus 4D divided by 2, this will be equals to how much? 32, because we need not to divide by 5. So A plus 4D will be how much? 32. That means 2A plus 4D equals to 32. That means A plus 2D equals to 16. So now you got two equations, A plus 3D equals to 20 and A plus 2D equals to 16. So now we will solve this here. You got A plus 3D equals to 20 and A plus 2D equals to 16. Let us say this is equation 1 and this is equation 2. If you subtract equation 1 from 2, okay, if you subtract equation 1 from 2, what you will get? Minus t equals to minus 4. So that means t equals to 4. Now putting here d equals to 4 in any equation, if you can put down, let us say putting in 2, we'll get how much? A plus 8 equals to 16, that is a equals to 8, d equals to 4. Now let us cross check it. 4 term is given 40. So let us see if it is t4 we are getting it 40 or not. A plus 3d, that means 8 plus 3 into 4, that is coming 20. So let us find 21st term. T 21st term will be a plus 20d, that will be 8 plus 20 into 4 equals to 8 plus 80, that will be 88. So this is your answer. So now let us see another question. Sum of the first n terms of an arithmetic series is given by n cube minus 1. Find the first 3 terms. So it's very simple. Sum is given for n terms. So Sn is n cube minus 1. Find the first 3 terms. So what we do, first we'll find first the S1, because S1 is nothing, will be T1, because there is only one term, so that will be a sum also. So S1 will be T1 equals to how much? This will be 1 cube minus 1, that will be 0. Now S2 will be what? S2 will be T1 plus T2, and that will be 2 cube minus 1, and you will get 7. So as you know that this is equals to T1 plus T2 equals to 7, and T1 is 0, so 0 plus T2 equals to 7. So you will get T2 equals to 7. So you will get the difference D, common difference, that will be T2 minus T1. That will be equals to how much? 7 minus 0 equals to 7. So now you got A equals to 0 and D equals to 7. So sum of the first n terms of an arithmetic series is given by this. So now you can find it out, the n terms. The first 3 terms will be what? T1, general formula will be A plus n minus 1d of an arithmetic series. So you will get, now let us start solving here. So you will get T1 will be 0 plus, first term is 0, second term is 7, already we have taken out, and third term will be what? Just add 7 to it, 7 plus 7, that will be 14. Just remove this. Okay, so first term will already we have calculated 0, T2 is 7, and third term will be 7 plus 7, that will be 14. Now we have to find, this is the A part. Now we have to find the 11th term. The 11th term will be what? T11 will be A plus 11 minus 1 into 7. That will be 0 plus 10 into 7. That will be 70. Okay, and see nth term will be what? Tnth term will be A plus n minus 1 into 7. So this is 0 plus n minus 1 into 7. That will be 7 n minus 1. This is the nth term. So all these 3 parts are easily solvable. Hope you understood it. Now let us practice some questions which came in the actual paper. So that will give more confidence to us, and using past papers, and we'll see that if we have learned everything to solve the questions. An arithmetic progression has first term 7, the nth term is 84 and the nth term is 245. Find the value of n. So a is given 7, nth term is given 84 and 3nth term is given 245. So first of all, we will apply the formula for tnth term, that is a plus n minus 1 d. So nth term is 84, means 84 equals to 7 plus n minus 1 into d. This is equation number 1. Now we'll get another equation, that is 245 for nth term, that is 7 plus 3n minus 1 into d. This is equation number 2. Now how we will be solving it? First, what we will do, we'll take 7 there, we'll get 77 equals to n minus 1 d. And similarly, taking 7 there, we'll get 238 equals to 3n minus 1 into d. Now this is equation number 3, this is equation number 4. We'll divide 4 equation by 3, fourth equation by 3. So we'll get how much? 238 divided by 77 equals to 3n minus 1 into d upon n minus 1 into d. d we cancel out. Now let us simplify this. On dividing by 7, you will get 7 3 the 21, 7 4 the 28, and this will be 7 to 11. So now it is not further divisible, we'll cross multiply it. So 34 into n minus 1 equals to 11 3n minus 1. So you will get how much? Let us solve it. You will get 34n minus 34, that will be equals to 33n minus 11. Taking 34 here and 34 here and 33 here, so we'll get 34n minus 33n equals to 34 minus 11. We'll get n equals to 23. So this, find the value of n. Now let us see another question. An arithmetic progression has first term 7, the nth term is 84. This is we have already done. Let us see another question. The first and the second term of an arithmetic progression are respectively this, where theta greater than 0 and less than pi by 2. Show that the common difference is minus 1 upon cos ki power 4 theta. The first and second terms of an arithmetic progression are given. So what we will do? We know a equals to secant square theta. Now d we can find it out how? Minus tan square theta into secant square theta minus secant square theta. This is what? Second term t2 minus t1. Okay. So taking secant square theta common, in fact minus secant square theta common. Okay, taking minus secant square theta common, you will get how much? 1 plus tan square theta, and this is nothing but 1 plus tan square theta is how much? Secant square theta. So ultimately we'll get how much? Minus secant की power 4 theta. Okay, so this is nothing but minus 1 upon cos की power 4 theta. So hence proved, hence showed. Now let us solve another question. The sum Sn of first n terms of an arithmetic progression is given by, find the first term and the common difference. See, S1 will always be T1 because there is only one term. So we'll get how much? 32 into 1 minus 1 square, that is 31. This is the first term. Second, S2 will be what? 32 into 2 minus 2 square, that will be 64 minus 4, that will be 60. So S2 is nothing but T1 plus T2 equals to 60. So 31 plus T2 is how much? 60. So T2 is how much? 29. T2 is 29, T1 is 31. So you got the first term. Now you have to find the difference. So D will be how much? T2 minus T1. So that will be 20 minus 31, that will be minus 2. So this is a common difference. So with this we will end the session here and hope you understood everything. Best of luck. If you have any problem, you can always mail me at or WhatsApp